Hi everybody, Unit 2 Limits, Subsection 3, Working with Limits. Part 1, Finding the limit of a rational function using factoring. Recall that from last section, when we evaluate a limit of a function that's continuous, all we have to do is substitute the value of x, or any other manipulated variable like a or b or whatever, okay, for any value of x that's approaching, and that will give us the limit of that function. Also recall that when we tried to evaluate a discontinuous function at the point or place of discontinuity, we algebraically got a result of 0 over 0. We then resorted to using a table or table of values to determine whether there was a limit or not. Okay, now it's time to use some of our skills from last unit and from our previous math courses to determine this limit without the time-consuming use of tables. Okay, so the first strategy we're going to use is factoring. All right, so number 1, find the following limits by factoring. Okay, the idea for this is we're going to factor the top and bottom, and hopefully we can get the 0 over 0 part to factor out. Okay. The first thing we're going to do is just make sure that this doesn't work. Okay, so let's see. So if x is 2, so 2 squared is 4. 4 minus 4 is 0. Okay, and then 2 minus 2 is 0. So this is indeed a 0 over 0. Okay, it's a good idea to check that. Okay, so once we know that it's a 0 over 0, now we can factor. So this is the limit as x approaches 2. Yes, you're supposed to write this every time. Okay, and then we factor the top, so that's x plus 2, x minus 2, right, difference of squares, all divided by x minus 2. Okay, so then this part factors. So now look, as x approaches 2, 2 minus 2 is 0, and 2 minus 2 is 0, so at the top and the bottom, the 0 over 0 part cancels. So really, this is now the limit as x approaches 2 of x plus 2. Well, the 0 over 0 has been factored out, so now we just sub that 2 into there. So 2 plus 2 is 4. Okay? So that's also a way of finding the discontinuity point, right? When you put the x value into the equation after the factors cancel. So anyways, the point of discontinuity would be 2, 4, and the limit of this function as x approaches 2 is 4. Okay, so we try that again with the second one. Okay, so again, this is going to be the limit as x approaches 4. Oh, right, yeah, 4 squared minus 16, that's 0. 4 minus 4 is 0. So it is a 0 over 0. Okay, so limit as x approaches 4 of x plus 4, x minus 4. Okay, so we just factored the top over x minus 4, so that cancels those. Okay, and then of course this is just the limit as x approaches 4 of x plus 4. So again, just substitute in, because now this part, the remaining part, is continuous, so 4 plus 4 is 8. Nice. Okay, so the next one, a little bit different, still a difference of squares on top, but just one of those things that happens in math. So this is going to be 2 plus x, 2 minus x, over x minus 2. I'm sorry guys, here I'm not even following my own device or advice. Okay, so 4 minus 2 squared is 0, 2 minus 2 is 0, so this is a 0 over 0 limit. Okay. Now remember what happens, or how we can decide which one of these cancels. We're looking for the stuff with exactly opposite, either exactly the same or exactly opposite signs. So here we have a plus x and a minus 2. Here we have a plus 2 and a minus x. So it's these ones that cancel. But remember, when we cancel this way, we leave behind a negative 1. So this is the limit as x approaches 2 of negative 2 plus x. Okay, then we put the 2 in. 2 plus 2 is 4 times negative 1. So this equals negative 4. Okay, maybe play that one again. Remember, when factors like those two, okay, divide, they have exactly opposite signs. So when it factors, it leaves behind that negative 1. Okay, number 4 is a little trickier. Okay, that uses one of the skills we learned from chapter 1. Okay, so this is the limit as x approaches 2. Oh, here we go again. Okay, so 2 cubed is 8. 8 minus 8 is 0. Okay, 2 squared is 4. Minus 6 times 2 is 6. So 4 minus 6 is negative 2. Plus 2 is 0. So this is a 0 over 0 again. Okay, so that's a difference of cubes. Okay, so for this guy, remember we cube root each one, keeping the sign of the first part the same. Okay, and then we square the second chunk, change the sign from the negative here. Okay, and then it's just x times 2, which is 2x, and then the last one squared, so plus 4. So that's how we factor the perfect cube. Okay, and then this one, that's just regular factoring. So factors of 2 that add to 3, so that's 2 and 1. And both, so x minus 2, x minus 1. Okay, so look, that part cancels, leaving us with a continuous part left over. So the limit as x approaches 2 of x squared plus 2x plus 4 over x minus 1. So now we just put the 2 in, so 2 squared is 4, plus 2 times 2 is another 4. So 4 plus 4 plus 4 is 12 over 2 minus 1, which is 1. So of course that gives us a limit of 12. Wow, that's fast. Okay, so we factored the top using difference of cubes. Okay, factored the bottom using inspection, crossed off the x minus 2's, and we went from there. Okay, so number 5. This one's a little bit different. Okay, now you don't know this obviously yet, but this is actually one of the forms of finding a derivative later on. So anyways, it's not a coincidence that the form looks like this. So anyways, if we put in 0, okay, so 2 plus 0 is 2, 2 squared is 4, 4 minus 4 is 0, and then of course h is 0, so this is one of those 0 over 0 limits. Okay, so now, I'll erase this. So now what we do is we have to simplify this out. So that just expands. Okay, so we end up with the limit as h approaches 0 of 4 plus 4h plus 4h, my goodness, that's funny. Okay, 4 plus 4h plus h squared minus 4 all divided by h. So the 4 and the minus 4 cancel. So this is the limit as h approaches 0 of 4h plus h squared over h. Now if you have a look at the top part, we can factor out an h. So h, 4 plus h over h. Those cancel, leaving us with just the limit as h approaches 0 of 4 plus h. So the 0 over 0 is gone, so now we just substitute that in. So 4 plus 0 is just 4. Great. Kind of a neat one. It went by a little quick, but that's okay because number 6, hey, look, it's a very similar one again. Okay, so remember, we expand this one out, FOIL it, okay, combine like terms, factor, cancel off the 0 over 0 part. Again, we should just check 1 minus 0, okay, is 1, 1 squared is 1, 1 minus 1 is 0, okay, and then divided by 0. Okay. Alright, so first bit, okay, so that's going to be the limit as h approaches 0. Okay, so 1 squared is 1, 2 times 1 times negative h is negative 2h plus h squared minus 1, all divided by h. So you can see that the minus 1 and the positive 1 cancel. So this guy is the limit as h approaches 0 of negative, whoa, what's going on? Sorry. Hitting the wrong buttons everywhere here now. There we go. Whoops. Alright, so you got negative 2h plus h squared over h. So of course that factors. The limit as h approaches 0 of h negative 2 plus h over h. So there the h's cancel. So we get the limit as h approaches 0. Negative 2 plus h, so the 0 over 0 canceled, So this one, just substitute the 0 into there. Negative 2 plus 0 is just negative 2. All right, so that's that one. Now, what happens if a function can't be simplified into another continuous function? Okay, so basically what happens if the 0 over 0 doesn't cancel, or what if it's not even 0 over 0? So I've given you a couple of examples here where it doesn't, and hopefully it'll help kind of cement the idea. Okay, so I want you to show that the limit as x approaches 0 of 1 over x doesn't exist. Look, there's no way to factor this, right? So there's no factoring involved here. If I just put 0 into there, I get 1 over 0. Well, the ones that work are zeros over 0. Okay, so 1 over 0, really that just means that the limit doesn't exist. Okay, does not exist. Now, how we can tell, remember the graph of this looks like this. Now, as I approach 0, so x equals 0, what happens? This side, as it gets closer and closer to 0, the y-coordinate becomes negative infinity. That was weird. I think I hit the text box there. There we go. Wow. Some adventures in tablet land. Okay, so this guy, he works out to negative infinity. As I approach 0 from the right, okay, this guy keeps getting higher, so that's positive infinity. And you can see that the two numbers don't line up. We don't approach a single number like we have with all the other ones. So we say here, our limit does not exist. Over here, again, we substitute in 4 plus 2 is 6, 4 minus 4 is 0. See, we don't even get the 0 over 0 limit. So we say that this limit does not exist. And if we were to look at the function here, if we make a quick sketch of this, so we have an asymptote at plus 4. Okay, anyways, the function actually looks, let's see, one, it looks something like this. Okay, and that actually curves and hits the 0 right there. Wow, that is a terrible asymptote. Here, let's try that one more time. It'll be a little better. Okay, curves. And it's like that. There's a 0 at negative 2. Not that that's important. The thing is, as we approach 4, right, as we approach 4, this guy and this guy, the bottom one gets closer to negative infinity, the top one gets closer to positive infinity. They aren't going towards the same point, so we say that the limit does not exist. Okay. Rewind this if you need anything else, or give me a call or text. We'll figure it out. Thanks, guys.